Hi, greetings of the day. Welcome to my channel AI. My name is Vidya. Today we'll go into an interesting topic which is Go data structures. We begin with linked list as an example. So to understand what exactly is a linked list is the data structure for storing collection of data in various forms. Unlike arrays, this is going to be dynamic memory, wherein linked lists are actually data structures that is linear in mode. Linear meaning we can traverse either in the forward direction or in the backward direction, as you see in the pictorial diagram here. If you traverse in the forward direction, it's referred to as simply linked list. If you traverse in both forward and backward direction, it is referred to as doubly linked list. A node in the linked list generally has data and then a pointer to the next node, as you see here. So you have 21 here, which is the data, and then 32 here, the data again at the second node. So you have one node, the second node, the third, and so on, and the last terminating node is terminated by a null pointer. The next has an address to the next node. You have the head node here and the tail node here, and the traversal happens in a leader direction, typically useful for performing lookups, insertion, and deletion. A typical representation of a linked list node in Golang goes like this. It's a simple structure with two elements, one representing the data and the other representing the next node, which is a pointer to the next node in the linked list. The data can be in any data type. It can be an integer, it can be a float or a string. And the next node can be a pointer to the next node in the linked list. Next comes the bunch of functions that are supported by the linked list. There are three primary functions supported by the linked list. They are insert operation, delete operation, and lookup operation. An insert operation can be performed to insert a node in the beginning of the linked list, the end of the linked list, or to the middle. Likewise, a deletion or a removal of a node can also be performed at any point in the linked list. And the lookup operation means searching for a particular node or a data value across the linked list can be performed by traversing the linked list in the forward direction in case of a singular linked list, or in forward in and backward direction in case of a doubly linked list. The time complexity is O of n and it's referred to as linear. You see a linked list here. There are elements starting from 21 over to 55. The first element in the linked list is referred to as head and the last element is referred to as tail. The first element that you see here is 21, which is the head, and the tail element is 55. The data values are 21, 21 again in the second node, and 43, 33, 44, and 55. And the next is the address of the next node in the previous one. Now we go ahead and see the insert operation. Consider a case we have a new node 33 and is expected to be prepended to the linked list, meaning it needs to be added to the beginning of the linked list. We go ahead and create a new node, and then here the expectation is that the head pointer needs to be changed. So it needs to be changed like this. And in case we want to append a node to the tail, then we go create another node 66. And if this node has to be appended, it goes like this. We change the pointer from 55 over to 66, and the 66 points to the nil. The value pointing to tail needs to be now 66. Now you can think of a node that needs to be inserted in the middle of the linked list. Let's say 55 or 50. Now 50 needs to be inserted between 43 and 33. So we change this pointer pointing from 43 to 33 direct to 50 instead. That's it. Thanks for watching. If you like the kind of videos that I'm making, consider subscribing. Thank you.